First topic for the day is going to be literal equations. Basically, literal equations are equations where you are asked to solve for a given variable among many other variables. So in this case, here's our equation. We're asked to solve for y, which means we have to isolate this term right here. And there's a lot of ways to go about it. If you'd like, you can do as we did in our regular equations and get rid of that denominator right off the bat, which I'm going to do. So I take and get rid of z by multiplying it to every term. I have x plus y minus za equals zb. And then I'm going to take and bring the za over. So I get x plus y equals zb plus za. I'm going to then isolate the y by subtracting x. And I'm done. Like I said, there's a lot of ways to get that same answer. I just try to use the preferred way that I would do it in a regular type of equation. Next. Same thing, we're going to solve for a. Again, a lot of ways to do it. I'm going to bring the d over first. I have f plus d gives me c times a plus b. I can get a fraction if I want. I'm going to multiply this through because typically they want this in simplified form, so they don't want an addition of two fractions in the end. So if I go ca plus cb is equal to f plus d, I subtract the cb. And then I have ca left. And then when I'm done, I have a singular fraction, which is what they would prefer, instead of the sum of two fractions. So there's your literal equations. We're going to turn this now into a conversation about some applications of algebraic nature. So, applications, otherwise word problems, basically come in three forms. You're going to have some number comparison type of problems. You're going to have like a pennies, nickels, dimes problem, something that deals with money or mixing things. And you're going to have likely distance, rate times time. And really there's a lot of other looks to word problems, but those three are going to be of similar nature in every problem that you're going to get. So this is obviously a geometrical problem. We're talking about a trapezoid, so let's draw out a trapezoid. Doesn't say it's isosceles, so I'm going to make one a little bit bigger than the other. It says one of the bases is 3 times the other length of the base, so I'm going to call this guy x, call this 3x. Height of the trapezoid, remember that's a perpendicular coming down here, is 12 centimeters, and its area is 120 centimeters squared. So now I've got to write the equation, and you've got to bring a little geometry knowledge from the past. We know the area equals 1/2 the height times the sum of the bases. And now we can just plug and chug most of this stuff to get what I need. We're looking for x first because we need both bases. So I have 120 equals 1/2 of the height. And then I have the two bases in terms of x. And then I just go ahead and solve. I'll multiply this first, which is 6. That's 4x. 240. I don't want to divide by 24. I'll just divide by 6 because I can do it in my head. 20 is 4x. And then 5 is x, which makes one base equal to 5 and the other base equal to 15. So now we're talking about a rectangle. can draw a better one of these with this program. Rectangle is 20 greater than its width. Okay, so there's my rectangle. And I'm going to say one is 20 greater than the other. So I'm going to call this x and x plus 20. And this is my length and this is my width. All right. And then if the width of the rectangle, so this part is going to be reduced by 20, and the length is increased by 100, the perimeter of the new rectangle is going to be twice the perimeter of the original. All right, so we're going to shrink this guy in the tall sense and expand it in the length sense. All right, so let's draw a new rectangle, and we'll make it skinny and not quite as tall. All right, so in this new rectangle, once again, they're going to take and decrease this width by 20, so that's x minus 20. And then they're going to increase this length by 100, so that's x plus 120. And the perimeter of the new rectangle is going to be twice the perimeter of the original. All right, so remember perimeter is equal to 2w plus 2l. All right, so now it says the perimeter of the new triangle, that's this guy, so it's 2 times x minus 20 plus 2 times x plus 120 is going to be equal to twice the perimeter of the original. Well, here's the original. Twice the perimeter of the original is 2x plus 2 times x plus 20. For most of these, I'm just going to set these up from now on because I'm pretty sure you guys are overly qualified to solve these equations. So there's your setup. Next, so here's the number comparison problem. We're talking about consecutive integers. So consecutive integers are numbers that are counting, obviously, and they come one after another. So if this is my first, and I don't know it, I'm going to call it x. My second is going to be x plus 1, and my third is x plus 2. And they say, find 3 integers whose sum is sum. We're going to add 3 of them. X plus 1. I'm just going to underline these to notate they're different. And x plus 2 is 16 more than 2 times the middle guy. 2 times the middle guy. All right, and then you've got it all right in front of you. Next, the sum of an integer is twice the sum of the next greater even integer, and is the same as the difference between 5 times greater, yada, yada. All right, so let's take this on again. This is a comparison problem, and it's talking about even integers. So in this case, we have 1, or the first guy, and that's going to be x. And then I'm talking about the next greater. So the second is going to be 2 greater because it's even. And we'll say the sum of that even integer, x, and twice the next greater, x plus 2, is the same as the difference between 5 times the greater even integer, that's the x plus 2, and 14. And we're set to go there. So in this case, notice you're going to get x as an answer, and they want you to find both, so you're going to need to get x plus 2 as well. Just make sure you answer the question when you're done. All right, distance rate times time. Some of you feared this all your life, and some of you have found a way to do it in your head. And some of you have actually found a way to do it algebraically. Since this class is called algebra, we're going to do it algebraically. Guess and check methods are just like figuring out numbers in your head or writing stuff down is not going to work. I'm going to ask you pretty much all year long to, first of all, write an algebraic expression and then solve it. All right. So I'm a big fan of these charts, and we know distance is equal to the rate multiplied by the time, right? And my general attack on these things is fill out a chart first, use it to get everything you can relative to the problem, and then write an equation. I also like to look at the problem, read it, and draw myself a picture to get an idea of what that equation is going to look like. So we start out from towns part, and we know that this total distance is 164, and they drive towards each other, one at a rate of 40 miles an hour and one at a rate of 48 miles an hour. So notice I've drawn it so that Karen goes a little further than the Andrew. And we want to know how long after Andrew leaves will they meet. Okay, so we're going to be solving for a time. All right. Now, it does say that the Karen begins 15 minutes after Andrew does. So that means Karen has traveled less time. All right, so let's label Andrew and Karen here. So if that's 15 minutes less time, and we're doing, notice we're talking in kilometers per hour. So this rate is in km per hour. That means I want to put the time in hours as well and work in the same units. So if we leave 15 minutes later for Karen, that's the time that Andrew went minus a quarter of an hour. And Andrew traveled X amount of time. We know each of their rates. Andrew travels at 40. Karen travels at 48. Now, here's where I stop plugging into the chart in terms of actually using this information and plugging in. Because right now I have two columns completely filled out, and I have a relationship between my distance, rate, and time. So I can multiply over now to get an expression for my distance for Andrew, and multiply over and get an expression for my distance for Karen. And then, now that I have this, I'm going to write an equation using this information, right? And I have everything I need right in this picture. So if I look at this, I say, well, Karen's distance, you can call it dk, and dA, those distances add up to 164. So I know that 40 x plus, well, let's just go ahead and do this right here, 48x minus 12 is equal to total of 164. And then I'll solve the value for x in the end, and x will give me the time that Andrew traveled. And the question asks, how long after Andrew leaves will they meet? All right, so it's going to say they're talking about the time for Andrew, and X will answer that question, so I don't even have to go any further. If I wanted to know how long after Karen leaves, then that's a whole different story. All right. Okay, so next is kind of like a money problem. It's really similar to the distance, rate, times time in the way that it solves itself, but if you know anything about banking and interest and all that kind of stuff, you put money in the bank, they give you a percentage interest. At the end of the year, you get some extra money based on the amount that you put in. All right? And what's happening in this case is we have two different interest rates. One is at 5%, and that's notated as 0.05, and one is at 8%, 0.08. And it turns out if you take the amount, multiply it by the percentage, you get your total interest. All right. Now, the problem in this case is it says, here's my total interest received, 720, or sorry, 272. And that's the total. So the sum from both of those. but they don't tell us how much in each that I get. Now, I guess you could use two variables if you wanted to, but we haven't discussed two variables yet, so I'm going to try to do this in one. I always call one of them x, and then I know that the two have to add up to 4,000. So if I take 4,000 minus x, then those two will add to 4,000. And then, like I said, we multiply these two columns over to get this column here. I get 0.08x, and for this guy, I get 0.05 times 4,000 minus x. Now, this is the total interest for the 5% account and the 8% account. And when I add up my total interest, I get 272. So 272 will equal that 0.08 times x plus that 0.05 times 4,000 minus x. Once I solve for x, I get the amount invested at 0.08, and then you have to take 4,000 minus that x to get the amount invested at 0.05. So you'll need to do a little calculation at the end. Lastly, talking about a mixture problem. And in these problems, it works out exactly like we just did for our interest problem. The relation between these columns, one column is going to be the amount of the solution you start with, the percent of alcohol in that solution, and then the total alcohol. And basically, you're going to multiply those two together to get the third. All right. And I think I probably should have put another row into this guy. So let's just do that now. All right. So percent of the mixture. I've got everything I need in this. So this guy's going to be, let's call this guy my 20 and 50 and 30. So I know this guy's 30, this guy is 50, this guy's 20. All right, now the amount of each. They want to know how many of the 20, so that's unknown, mixes with 40 of the 50 to get the 30%. So think of this as one bucket and think of this as another. If I dump them together, then I have x plus 40. And then multiply across 0.2x and 0.5 times 40. We could put that as 20, but I didn't. And this is going to be 0.3 times x plus 40. Now, what we know is there was some alcohol in the 20% solution. Here's the total alcohol. There was some alcohol in the 50% solution. Here's their total alcohol in that. Dump the two buckets together, and this is the alcohol that was in the 30% solution, but it equals the sum of the alcohol in those two. So again, 0.2x plus 20 is equal to 0.3 times x plus 40. And we want to know how many liters of the 20% solution. So we're looking for x in the end, and that will be our solution. That's all we've got today, and we'll see you next time.